explaining object-oriented principles, but before doing so, I will come back and first define again what is object-oriented programming. Anybody can tell me what is object-oriented programming based on what we just saw before?
We can create objects.
Okay.
Objects that we want when coding.
Okay, very good. So basically, it's a way of breaking our program into objects. Yeah, object. So there might be a little bit of confusion here. This is a style of programming. This is one way of programming. You saw another way in 151. You did the whole course, and you didn't even come near this object-oriented programming. What did you use in 151? No, C is a language, but the style of programming, you broke down your program into functions, and you just solved many problems. You solved many problems. You even did a project, and you solved it by breaking down your program into functions. Okay. In object-oriented programming, the difference here is that we break down our program because modularity and decomposition is a must. You cannot write your program as one unit or one piece. You have to break it down. In object-oriented programming, how do we break it down? Into objects. Now, objects, there is a concept of objects and a class. Again, don't let these two concepts confuse you. What's the difference between the two? Yes, the definition of an object. So when we start decomposing our solution into objects, usually it's easier for us to identify objects rather than classes. So that's why it's called object-oriented programming. And these objects, from where do we inspire them? From where do we get them? From the real world. Okay. So it's easier for us to say, let's say in Banner or in a university context, if we want to create an application or a program to manage registration, to manage student records, to manage their transcripts, we will build an application. Some people already built it, called Banner. And basically in Banner, you will find objects inside Banner that reflect real-world objects. So in real world, in a university, we have students, we have course, we have section, we have instructor. So all those are kind of objects that we can program and represent in our program. Yeah. Now, when we start creating objects, before I can create an object, what do I need to do? Create a class first. So although I identify objects, but before I can create them and program with them, I need to define what this object is. And the definition of an object is the class. So if you recall, for example, we created in the examples we did together, we created an account class that has some attributes and methods. And then after we create the account class, we went ahead and created many objects of that class. For example, created Sarah's account, Ali's account, Ahmed's account, and so on. Okay? That's basically the idea. So in object-oriented programming is a style of programming where we use objects, and these objects interact with each other. They call each other to do the work that is expected from them. And this object-oriented programming relies on some principles, some basic principles that we keep them in mind when we design and develop our application. Yeah? And these principles are, I will explain one by one. That's the goal of this session. And the key thing to remember about these objects represent a real-world concepts. So that is the power of object-oriented programming. We have some real-world concepts that we find in the problem that we're trying to solve, and we take these concepts and we reflect them in our program. So the gap between our program and the real world is small. So we can. It's much easier for us to do that. Okay. So if we look at a running program, if we open a running program, let me show it to you. Oh, sorry, I lost something. Yes, here it is. If we look at a running program, let's say in 151, if you open your program and see it running, you will see it as a set of functions calling each other. While in in this course 251, if you open a running program, you'll see it as a set of objects. These objects have attributes and methods, and they will be interacting with each other. That's basically the difference. And these objects are a representation of real-world objects. That's the key idea of object-oriented programming. Okay. As I explained, these objects encapsulate, which means inside them you find two things. You find attributes and you find methods. And typically, as I explained, the attributes are made private and methods allows us to manipulate these attributes. And these are just examples. We saw some of them. I discussed with you before some of them. So in the real world, we have a car. And we can have a car as a class in our program. And this car, it can have color, the liters of petrol in the car, for example, the number of kilometers it has traveled, and so on. And it has methods. You can accelerate, you can stop, and so on. Same thing for light bulb. It has attributes like whether it's on or off, and you can switch it on, switch it off. We did an example of a bank account. It has ID, name, balance, and you can deposit, withdraw. That's basically the idea. The idea, we have these real-world objects and concepts in the real world, and we represent them in our program as classes with attributes and methods. That's the key idea. And this is encapsulation in a very clear way. You can see here the attributes here are black box, are inside the black box. They are not visible to the outside world, and you can only access them via the public methods. Yeah, and you can decide which ones you want to make accessible and which ones you don't want to make accessible, or which ones you want to make directly accessible and which ones you want to make indirectly accessible. Such as, for example, this balance. There is no set here. There is only with deposit and withdraw to change it. Okay, now, as I explained, before I create an object, I need to create a class. Okay, and a class, if you look at it carefully, when you create a class, you are creating a programmer-defined data type. This is a very important word, the important sentence. So Java, as an example, comes with many built-in types. Some of them are value types or primitive types. Some of them are classes, such as int and float and double. These are primitive type. And a string, it's a class, for example. Now, when you write your program in an object-oriented style, you can create your own classes that are specific to your application. And that's the power of object-oriented programming. It allows you to create programmer-defined data type. Because once you create a class like a student, it became a data type. And you can use it to create objects from it. And when you create an object from a class, you are doing instantiation. You are instantiating an object from a class. It's just a term. Again, creating an object from class, we call it instantiating. And this instantiation comes from the word instance, which is an example. Okay? And this is already explained. A class contains private attributes and public methods. You need to be careful to differentiate between a class and an object. So class is the definition, and an object is an example of a class. So for example, the class is a student, and we might have Ahmed as a student with his own attributes. Like for example, his own ID, his own name, phone number, address, GPA, and so on. Sarah is yet another student, another example of student with her own attributes. Okay, but both of them are created from same class. So we create a class once, and then from the class we can create as many objects as we wish. So it is important to keep in mind that an object is an instance of a class. Now coming to the pillars. The pillars is like the principles, the foundation upon which the object-oriented programming is built. So some of them we already seen. Okay, this one you should be able to explain, and this one you should be able to explain. Okay, the first one, the first pillar of object-oriented programming is modularity. What this word means? Sorry?
Dividing the program into parts.
Divided the program into pieces or units. And what is the unit of decomposition in object-oriented programming? Object. Yes? So that is the idea of modularity. You don't go and create an object as one piece, you divide it into pieces. What are these pieces in object-oriented programming? Objects. And these objects, you inspire them from the real world. That's the idea. Now, why do we need modularity? Why it is very, very important to have modularity?
For readability.
For readability, yes.
Easy to maintain.
Easy to maintain, easy to develop, easy to design, and so on. You can even divide the work among yourself. So if you have a program and you divide it into units, you have a team of 3 members, you can divide the work. But if you have it as one piece, you cannot divide the work. Okay? What I mean here, what we mean by easy to maintain, what does that mean?
So maybe if there was a fault in one of the objects, you can easily get to that.
Very good. Yes. You see, like in your car, for example, the engine is not one piece. Why they didn't make it one piece?
Because if something went wrong, everything...
Yes, if something went wrong, it's very, very hard to fix it if it's one piece. But luckily now, everything, the engine, if you open it, it is modular. You might have, you might see some heating coming up in your dashboard. The car is heating. Most likely it's the radiator problem. Maybe it's leaking or something. So all the mechanic will do, take off that radiator, either fix it or bring a new one and put it. And you move on, yes? Easy to maintain. Because you can go to the piece that has the problem, you fix it or replace it, and you are good to go. Okay? But if it's one piece, it's very hard. Maybe you have to take it all the way to the manufacturer, and they have to, I'm not sure what they will do. Okay? It's much, much harder. Yeah? That's the idea here. Okay, so modularity is very, very important to reduce complexity. And this is a very generic kind of solution or technique that humans use. Whenever we face complex problem, we break it down. Okay, we don't bring our white flag and say, "Khalas, we cannot solve it." No. What we do, we break it down into sub-problems, and then we tackle one sub-problem at a time, and hopefully we solve those smaller problems. And then we put these sub-solutions together to construct a big solution. That is the idea of modularity. And we do this to make it easy to design, implement, operate, and maintain. And also reuse. This is very important. If I have some pieces in my program, because it is broken into pieces, there is more likelihood I can reuse it in other contexts. Okay? So for example, if you remember, like, let's say the math class we saw last time, that comes with Java. It has a lot of functions that are reusable. You can use them in many, many contexts. Whenever you want to do absolute value, for example, you can just say math.abs, it gives you the absolute value, for example. Or you have a list of numbers and you want to find a maximum. You just call that method on the math class. So it makes your logic reusable. You can use it in other contexts. Maintainable, easy to change, easy to fix issues, and so on. And there are, as I explained before, there are 2 major ways of doing it, decomposition. One way is functional, and the other way is object-oriented. Functional, you already saw in 151. And basically, in functional, the way you do it, you say, okay, typically, one way of doing it, you say, okay, these are the steps of my solution. So my algorithm or my steps, step 1, 2, 3, 4, most likely you will say each step becomes a function. Okay, one way of doing it. But in object-oriented programming, it's a totally different way. the way you break down your program. So you first, how do we do it in object-oriented programming? How do we decompose our program into objects, yes? So basically, I go to the problem I'm trying to solve and try to find what are the major concepts, the major objects that are present in that problem I'm trying to solve. I gave you the example of banner. We have, if you look at banner, what are the major objects or concepts we have in banner? We identify them, let's say student, course, section, schedule, classroom, and so on. And then once we identify them, we go to each one and say, what are the attributes of that object and what the object can do for us? Yeah. So for example, if we take a section in banner system, section, what attributes we can have in a section? CRN, the course to which this section is related to, the campus or the location where the section will be offered, the instructor, and the schedule, the time in where it will be delivered, for example. Okay. And in terms of method, what you can have. Maybe you can have register, drop, close section, increase capacity, decrease capacity. Which is increased capacity, yeah? Increase the capacity, reduce the capacity, and so on, yes? You get the idea. So, and then you move to, let's say, course, and you move to schedule, and so on, and you start basically designing your program that way. We'll see how to do this as we move forward, especially in your lab, but just keep in mind that's how we do it. It's a very different way of thinking, of organizing your solution. One way it focuses on steps, which is the functional decomposition, and the other way, it focuses on identifying objects and then looking at each object and say, what attribute this object has, what functions it can do for me, and putting the attribute and the function under one unit, and you create a class for that. Okay. And as I explained in the functional decomposition, your program is made up of functions. In object-oriented decomposition, your program is made up of objects, and objects have attributes and methods. Okay. The power of doing this is that in object-oriented programming, you will come up with some objects that reflect the real world. Okay. Unlike the functional programming, it's not a real reflection of the real world. Okay, we never came across a function walking down the street. Okay, but we saw cars, we saw classrooms, we saw students, so though we find objects we find in the real world, we find them also in our program, and that gap between the real world and our program is reduced. That is the power of object-oriented programming. So the second concept or second principle of object-oriented programming that we already saw is encapsulation. What is this concept? Just to remind ourselves in one sentence. Putting attributes and methods. First, putting attributes and methods inside one class.
And making attributes private.
Yes, making attributes private and providing set and get methods for them. And if we wish, we can do validation when we do set. And also, in some attributes, we can even make them not changeable directly. Yeah, that is the idea of encapsulation. Now, abstraction. What is abstraction? We also covered it. What abstraction really means? We are inspiring our objects from the real world. Okay. Now, when we inspire this object from the real world, we don't just try to capture everything about that object. We only focus, when we define the class for that object, we only focus on what is important for our application, what is relevant for our application. For example, you see the student as a class, or a student as a real entity that exists in the real world. Student is a very complex creature. There are so many things we can say about students. But when we represent the student in our program, we only focus on attributes that are related to our relevant and important for our program. For example, in Banner, when we represent a student, when we define a student class in Banner, what could be the attribute we should focus on? ID, name, first name, last name, email, date of birth, major.
ID, the Q.
Yes, the ID, QUID. Do we care? Maybe nationality. Is it important?
No.
It is important in Banner. Why is it important? Because maybe there's different payments for, maybe for Qatar is no payment, for non-Qatar maybe there's payments, okay? You see here, this is important. Otherwise, it wouldn't be important. Okay, what about the height? Maybe the colors of the eyes, or whether the student has a pet or a cat, whether a swimming pool, which movie they like. Is it relevant? No. We just abstract what is relevant for our program and ignore other details that are not relevant. Yes? So students can do lots of things. Okay? They can paint, they can sing, they can write poetry, lots of functions. When it comes to Banner, do we really include those functions or those methods? They're not important for our application. So we abstract only the important elements related to the object that is relevant and related to the problem we're trying to solve, and ignore the rest. That's one way of looking at abstraction. So abstraction means two things. So in abstraction, what I'll do first, as I said, I identify objects from the problem I'm trying to solve, and for each object, how do I define each object? By creating a class. And when I create a class, what I'm really creating? A new data type, and this data type is really specific to my application. It's not very generic; it's specific to my application. And basically, these data type, these classes, even the terminology I use, even the terminology and the names I use are inspired from the real world, from the domain. Remember in the bank account, if you remember. So, for example, we had deposit and withdraw. We didn't use the word put money or add money, or we used deposit. Why did we use the keyword, the verb deposit, rather than other verbs? This is the terminology of the domain. Thank you. This is very important. So you can see here we try as much as possible in our program to reflect the real world. We use the same concepts, we use the same terminology. So it is a good reflection. So we don't have a big gap between the problem we're trying to solve and the solution we are writing. That is the idea. Okay. Abstraction, another way to look at abstraction is a simplified representation of something, only focusing on essential characteristics relevant for our application. And as I explained, students that we represent in our Banner program is, of course, a very simplified representation of student. Yeah, that's the idea. Even for car, when we present it in our class, in our program, if we have a class called car, we will not capture everything to do with the car. We only capture what is relevant. Okay. So, for example, if I am creating an application to manage parking, which cars comes in, when they came, what time they left. And some parkings you need to pay. I have an application to manage this. So I don't need to go through and describe the car, maybe just the number plate, maybe the color, maybe the make. This is more than enough. I don't need to go through much more details than this. Although the car, if I want to describe it, I can, you get to the manual of the car, there's so much details, but I only focus on what is important for the application I want to build. But if I am creating, let's say if I am creating an application to manage selling parts of a car, of course, I need to go through all the details and capture all the details because they are relevant for the application I'm trying to build. Yeah? So the abstraction, the level of abstraction based on the application. I only extract or focus on what is important for my application. That is basically the idea of abstraction. Okay, another way of thinking about abstraction is grouping things of the same type as one class. So for example, if I have a same example of car park, instead of having one class for truck, one class for bus, one class for car, because in the car park, not only cars will come, many types of other, what we call it in this case, vehicle. You see here, I abstract all types of cars instead of calling my class a car. What is a better name? Vehicle. Because if I call it car, then what if there is a bus coming in? Then it doesn't fit in my class. So I abstract this into much higher level that can accommodate multiple types of objects. For example, in QU we have a student, or let's say we have three major types of people in QU. We have student, we have faculty, and we have administrators. Okay. Now under faculty it groups teaching assistant professors, associates, and so on. Okay. Under admin it covers a range of people. So if we abstract, we might group multiple objects and abstract them as one class. That is another kind of interpretation of abstraction. Okay. So in here, multiple types of transport vehicles, I abstract it as a vehicle. Multiple types of animals, I abstract them as animal. Okay. So, for example, if there is a pet hospital, for example, I just create a pet class, and it covers any type of pet. It could be a cat, a dog, I don't know, elephant, it could be whatever. Okay. So, depend what I'm trying to do, I can group a couple of objects and abstract them as one class. Is clear? Okay. So this is just to give you some examples. For example, we have different types. If we want to abstract all people in QU, regardless of their type, I could have, for example, QU member, or it could be person. And this person can cover all types of people. It could be students, faculty, administrators, one abstract class, which is person. I gave you this example here. I have a car, I have a bus, I have a truck. I can abstract them as vehicle. Yeah. In here I have a rectangle, a triangle, and many other types of shape or polygon. It covers all these type of shapes. So abstraction, grouping of objects, I can create one class for them. I don't need to create a class per object. Is clear? Concept of abstraction. Just to summarize. The first thing this abstraction means, I am inspiring my objects from the real world. And these objects, I don't need necessarily to create a class for each object. I can group those objects and create one class to cover multiple objects. One definition to cover multiple objects. That's another idea. That's the main, let's just focus on those two main ideas. My objects are inspired from real world. Grouping of objects could be defined in one class. Please, 10 minutes. Okay, moving on. This is an example. Or maybe I put here faculty. You see in Banner, some kind of registration system. These are the abstraction I can come up with. I have student, schedule, faculty, course, section. For example, yeah. You see here, I didn't call it professor or TA or lab instructor, or I called it faculty because it is a higher level abstraction. It's an umbrella under which many types of instructors can fit there. I don't need to create a class for each one. Yeah, that's basically the idea of abstraction. Encapsulation, By now, it should be very clear. Attributes private, attributes and methods in one unit, attributes private, methods public. Okay, the other two more left, I will cover them super quickly. There is inheritance and polymorphism. Inheritance and polymorphism. And by the way, all these concepts are practical concepts. So we will see them. Some of them we already seen, and some of them we will see them. But let me just give you a glimpse. What do you think inheritance means in this context of object-oriented programming, or inheritance in general? Well, let's say in a vehicle, let's say if we take the example of, vehicle, let's just take an example of car and bus, just as an example, okay? So lots of things are common. So I put them in superclass vehicle. So for example, what is common between car and a car and a bus? What is common between them?
Number of tires.
Sorry?
Number of tires.
Number of tires.
Driver.
Plate number, the color, the made, all of, like whether it's Toyota or Nissan, all of this is the same, yes? What could be different? What do you think? Number of seats as an attribute is the same. Yeah. Tires, no, those are attributes. You are talking about objects now.
Maybe the way we'll be using the bus and the way we'll be using the car, for example. Like if we were building an application for, let's say, a Karwa, we'll set a destination from where to where, and then there is a route. But in the case of car, we don't have this.
No, this is different. I will come to this later. I will come to this. But let me just think of some silly differentiation. Like, let's say in a bus, you might have a level, the number of levels. Maybe we don't see them here, but some buses have 2 levels. Like in London, for example, buses has 2 levels. Some buses has 1 level. So, for example, the number of levels is an attribute specific to the bus. Do we have a number of levels in car? I haven't seen it. Okay, I haven't seen any car with levels. Yes, you can see it. You got the idea. But the number of seats, number of wheels, those are common attributes. Yeah, you can see here the number of levels is specific to the bus.
So we can use another example, like the university have the 3 types, like faculty and students and the
administrators. Yes,
yeah.
Very good.
These 3, they have the same accounts, but different methods they can use.
Yes. Let's focus on attributes, for example. This is a very good example. Thank you. Basically, there is, let's say we have QU member as a superclass, and all members, whether it's students or faculty or administrator, they all have ID. Yeah, they all have first name, last name, email. Okay, but faculty has extra property. Can somebody give me one extra property?
Like having access to some things.
No, as attributes, just to make it easy for us.
Whether they're an associate professor or professor.
Okay, for example, the rank. You see here the rank is specific to the faculty. Students don't have rank. For example, office number. Do you have office number? No, I have office number. You see here the attribute is specific. We all share some common things, but each of us has specific attributes. You have GPA. Do I have GPA as faculty? No. You get the idea. Yes? That is the idea of inheritance. We will have some class that have common stuff, and then we have subclasses that inherit the common stuff and add some specific attributes. Is this concept clear? Very, very powerful concept. Why do we do this? Why do we do this inheritance? In one word.
So maybe we don't need to create the same attributes for all the objects or all the classes.
Yes. In one word. In one word.
Convenience.
One word.
Reuse.
Reuse. Thank you very much. That's it. Reuse. You create those common methods and common attributes how many times? Once. And then you inherit them in another class. There's one more concept related to inheritance, somewhat. It's called polymorphism. Polymorphism. Very big term, scary term, but its meaning is quite simple. Anybody? Poly means there is multiple.
Yeah.
Okay. Morphism, multiple forms. What does that mean? For example, let me give you an example. Like we have, for example, animal, yes, as a class. They all have a method, let's say talk, or let's say make noise, or make a voice, or emit some sound. Yeah, they all have, let's call it talk, although maybe it's not talk. Maybe they talk. Okay. Now, this talk, they all have talk, yes? But do they talk the same way?
No.
Different implementation. So the cat will say meow, and the dog will say, you know, their own voice. The bird will say some other voice, but all of them talk. Yeah. So polymorphism means you have multiple classes. They have the same method. What is the difference? They have exactly the same method, different implementation. That's what polymorphism means. And polymorphism is a very, very powerful concept. We see it all around us in the whole universe. There is same operation, different implementation. For example, there is circulate or dawaran. Okay, there is dawaran of blood in the body. Okay, it has different implementation, different purpose, different. There's dawaran of كواكب حول الشمس. There is dawaran of wheels. All of this is the same, but different implementation. Totally different implementation. Okay, but it's all. We just need to understand one thing, which is circulate. Okay, but the way it is implemented is very, very different from one object to another. Yes, that's the idea of polymorphism. And with polymorphism, it makes it easier for us to use and understand. If we have animal, for example, and we just need to have one method that we need to learn, which is talk, but when we implement it differently. But whoever wants to use animal.talk, they just need to learn one method and use one method.
So this is convenient.
Very convenient, yes. It's more for convenience. Yeah. So we use polymorphism more for convenience, similar to overloading. You remember overloading? But overloading is very different than polymorphism. What is overloading? Same name, different parameters. And why overloading is important? Yes. More convenient, more easy for us to learn. For example, as developer, I only need to learn one method, let's say sum. And I can use sum with 2 numbers, with 3 numbers, with an array of numbers. I don't need to learn, or even when I remember, by now you already know, when you put when you put an object, dot, what you see? The methods. You won't see so many methods confusing. With overloading, you see one method with different parameters. Yes, more convenient, more easier to remember and learn. Similar purpose to polymorphism, but polymorphism is exactly the same method name, same parameters, but different implementations. Yes?
Depends on the class.
Let me show you. Sorry, I know I am late. I just want to finish with this one. Sorry. Just for you, because a picture worth more than 1,000 words. This is how inheritance looks like. Can you see it? This is employee, and this is part-time employee, and this is full-time employee. Sorry, just focus with me 2 seconds. Okay, so you see employee, they all have an ID, name, and start dates, all of them. But for part-time employee, they have an hourly rate. We pay them by hour. But for a full-time employee, we don't pay them per hour. They have a salary and they have an office number. But part-time employee, they just work from wherever. They don't have an office. You see here, there is something common and there is something specific to children. And this is the reusability. You put this common, you write it once, and then you inherit it. Now, polymorphism this is how it looks. You see here, I have an animal, and they all have a name and talk. And then I inherit. There is dog, there is cat, and there is bulldog. Okay? Now, all of them has talk, but the implementation is totally different. So this is when the cat, this is how it talks, the meow, and this is the uff, and this one is the scary one. You see, they all talk, but different implementation. Yes? And I will show you the benefits of doing this. I can put all of this in one array and go through them and say talk. I call one method and I get different behavior based on the object. If it's cat, it will say the meow. If it's small dog, it will say ah, and big dog will say different word. You get the idea. So polymorphism, same name of the method, different implementation. Yeah. Overloading is different. Same name, different parameters. Yes? So I hope it's clear. Of course, we will come back and visit this and see it in practice. We will practice this in the coming sessions.